Is it 7.5 or 395 though? 395, yeah. So you see how I'm writing this out as I'm recording? If you're going to watch this, what would it be beneficial if I did instead? Paused it before I wrote it all out. So on some of your videos, everybody, you sit there writing things out and explaining what you're writing, like narrating what you're writing, and then also not using the pause button. Please use that, okay? Please use the pause button. So what could you do first on this? There's a couple options. Is this an expression or an equation? Expression. What could you do first? Yeah, Alex. You could flip it. You could just immediately flip it. So you can make it 3p. Either way, Mar. Either way. You could factor first. You could do whatever you'd like. He wants to flip it, which is totally fine. That's usually what I do. So now you could what? Factor. What is the top numerator factor into, Mar? 3p minus, yeah? P minus 2, yep. All over p plus 5, which doesn't factor. And then you multiply that by, what's the next fraction factor into, Milo? What can you pull out of 8p and 40? 8, and what's left?
P and 6.
Nope, 5, good. And then what's left on the bottom? What is that right there? Can someone tell me what that is, Mar? What is that?
P minus 2, P plus 2.
Yeah, it's difference of squares, exactly. And now that you've done that, do a bunch of things cancel? Yeah, that's gone. That's gone. And what are you left with?
3 times 8.
Yeah, so 24p all over what? P plus 2. There's a p right there. And then you're done. Does that make sense, Nick? Okay, so this one, what should I do? One word. What should I do first? That's good. Factor. Let's factor. Can someone tell me what the first denominator factors into? What can I factor out? 2x, and what's left? X minus 4. Thank you. I just watched this video. Someone did this one. Plus 3 over, what is this? This is what? Difference of squares. So that's going to be x plus 4 times. Yeah, exactly. So now we need to add fractions. So what do we need? We need a common denominator. We need a common denominator to add fractions. What is our LCD going to be?
2x times x plus 4.
Exactly. So you need to glue on what's missing. So what's missing on this one right here? So you do 2x over 2x. When you do your work, make sure you actually write out what you're saying. Some of you are like, I'm going to multiply by 2x, but then you also multiply it in the denominator. You have to write out what you're saying and say what you write out. So on this one, what's missing on the other side over here? X plus 4 over x plus 4. So what does this become? 7 times x plus 4 plus 3 times 2x. And what's the new common denominator? 2x, x plus 4, x minus 4. We're not done yet because what should we do?
Multiply.
No, you do not multiply unless you absolutely have to, and there's something else you can do. Well, yes, you can multiply where, though? I'm sorry. On top. I'm sorry. I thought you meant the bottom. My mistake. So you distribute on the top, and you end up with 7x plus 28 plus 6x all over the same thing, right? What does that simplify to on top?
13.
X plus 28. And sometimes you can factor and then cancel something new out. The thing is, can you factor the top? No, because what number is prime up there? 13 is prime. So you are done at this point right here. You are done. You don't need to pay attention to it. It's just that the important stuff is listed in 2 places. Direct variation, they add a lot of words to this. Any relationship between x and y that can be written as y equals kx, where k is a, no, it's recording. It's recording. Where k is a constant is direct variation. This is a line that passes through what point? What point does that always pass through no matter what k is? So for example, y equals 2x is direct variation. Y equals 7x. Y equals pi times x. What point do all 3 of those lines go through? There's one point that all 3 of those lines all go through. There's one point that makes all 3 of those true. 0, 0. Every direct variation function is a line that goes through the origin. These are really straightforward because have you dealt with lines before? Yeah. You're going to spend your time trying to find k values, and generally speaking, finding the k values, not that bad. It's kind of like the word problems we just worked on. Building the equations was the work. Working with the equations, relatively straightforward. So for example, Milo, give me a number, give me any x value you want. Give me an x value. So let's say x is 2, and Connor, give me a y value. 7. Okay? So let's say I said that x and y vary directly. You now know that y is equal to k times x. But when y is 7, x is what? When y is 7, x is 2. You just made that up, okay? So what do we need to find? What are we interested in finding? So what do we plug in? We take x and we plug it in for x. And we take y and we plug it in for y. So what does that allow us to get? 7 is equal to k times what? 2. So what does k equal, Mar? 7 divided by 2. So what is the relationship between, what is this direct variation relationship? It is y equals what? Instead of k, what do we write? Okay, k is right here. 7 over 2, thank you, times what? X. When I ask you these questions, I'm not being clear. I will try one more time. I'll try again. When I ask you these questions, I'm telling you that x and y vary directly, so they must follow the equation y equals kx. Your entire problem at this point is to try to find k. How do you find k? You plug in the value for y and you plug in the value for x. So what did we find? We knew that 7 was equal to what?
Y.
K times 2. So k was equal to?
7 over 2.
7 over 2. So now that we found k, we now know the relationship between x and y is y equals 7 over 2 times x. You have just found your first k value. What's the point? What kinds of questions will you be doing? You'll be doing questions like this. You'll be told that two things vary directly. What kind of function are you working with if you're told that two things vary directly? A direct variation function. What kind of function is it? It is a linear function that goes through the origin. So on this one it says, Eva Luckman is paid an hourly wage. 1 week she worked 43 hours and was paid $795.50. How much does he earn per hour? Oh, okay. So what does that tell us? It says they vary. First of all, it says we're going to tell you that it's direct variation. So we need to label our variables here. Which one do you want to be x and which one do you want to be y?
Y can be 795.
So y is going to be, so this will be your y variable and this will be your x variable. So what do you know? Because they're varying directly, y is equal to k times x. What are we trying to solve for? The k value. So we have 1 point. When y is 795.50, so 795.5 is equal to k times what?
43.
K times 43. So if we want to solve for k, what do we divide by?
43.
So k is equal to 795.5 over what? 43. And what would you need in order to do this? Probably a calculator. Could you do that for a second? Can someone just do that real quick for me? Important. Mar just asks, how do you know which one's x, Connor, and which one's y? You can decide. You can do it either way. But in either way, you just have to do a reality check at the end. So the point is, if it's 18.5, what does that represent? You know that every time this changes by 1, they make one more unit of earning potential, right? So the idea is every time this goes up by 1, she earns $18.5 more dollars, and that should make sense when you check this because 18.5 times 43 is going to be 795.5.
So you're saying I could make 43y or...
You could, but then if you did that, then you would. If you did do that, you would get a much smaller number, and it wouldn't be the hourly wage. It wouldn't be the hourly wage because another way. So the 100% proper way to think about this would be the amount you earn is equal to what? Hourly wage times what?
Times how much you put.
Number of hours, right? So this is where you would start with if you want to disassemble it to the beginning. And you know, in this case, that we want that's our 795.5. And we know that this right here is 43. So that's what we're solving for. If you could label it differently, but you really want to just be careful about it. The way you can really be sure, do a reality check at the end. Do a reality check. Someone says that you have a spring and a force of 150 newtons stretches it 8 centimeters. 150 newtons is the amount of force, stretches it 8 centimeters. So it's asking you how much will a force of 400 newtons stretch the spring. So, what?
Proportion problem.
It could be a proportion problem, but we're not solving it as a proportion problem right now, okay? You could. Once again, you can do many things different ways. I'm teaching you another way to do this one, but you're absolutely right. You could do this as a proportion problem. Absolutely. So what they tell you is that the distance it stretches is equal to k times the force. So what does it tell you the original force is?
150 newtons.
150 newtons, yes. And what does it tell you the distance is? 8. So what can we now solve for? So in this case, k is equal to 8 over 150, which is 4 over 75. So we know for this one spring, we know that the distance it stretches is equal to 4 over 75 times the amount of force exerted on it. What does this question ask us to find? How much will a force of 400 newtons stretch the spring? So where do we plug that in? We're given is that force or distance? So we plugged it in right there. I'm just saying the distance when it's 400, when F is 400. So what is the distance when you have 400 force on there? It's going to be 4 times 400 over what? 75. That's, what is that, 1600 over 75? Does anybody know what that, can anybody do that in their head? Let's practice this. What's the greatest common factor of 1675? What's a nice factor of 75?
15. 25.
25. So that's 25 times 3, right? How many times does 25 go into 100?
4.
How many hundreds are there in 1600?
16.
What's 16 times 4?
Oh, okay. 64.
25 times 64. What can you cancel?
25.
So what are you left with? 64 over 3. And that's going to be, anybody know what that is? 21 point what?
21.3.
Correct. So what does this tell you? If you put 400 newtons of pressure onto the spring, how far does it stretch?
21.3.
And I think they give it in meters, right? Meters. The idea is you have a line that goes through the origin. When you have y equals, what was the general equation of a line? You like this, right? What did m represent?
Slope.
The slope. In this case, we have an invisible b value. What's the b value in this? We're adding 0, and instead of calling it m, we're calling it what? K. K is just going to be the slope of the line. That's it. Okay, so is going to correlate to y equals k over x. Y equals k over x. So Connor, give me a value of x.
4.
Nick, give me a value of y. 12. Everybody, if these vary inversely, find me the k value right now. K over 4. So how do you solve for k? So k is equal to 48. So whenever you see inversely proportional, all you write is y equals k over x and solve for k. That's it. That's it. Figure out the rest of this. If 10,000 syringes are produced, the cost is $2. So what does that mean we can do? 2 is equal to k over what? 10,000. So can we find k now? What's k equal to? 20,000. K is equal to 20,000. So can we write the actual function now? What does it mean? C is equal to what? 20,000 over x. There's our relationship. And now it says find the cost of producing 25,000 syringes. Where do we plug in 25,000? We take this 25,000 and we plug it in for x. So the cost of producing 25,000 syringes is equal to 20,000 over what? Can you cancel some zeros there? Yeah, that goes away, right? And what are you left with? 20 over, which is 4 over 5, which is how much? 80 cents. 80 cents. So what happens to the cost per syringe as you make more of them? It goes down. Can it ever get to 0 with this function? Can you ever get to 0? So as x gets bigger, what happens to the cost? As x gets bigger, the cost goes down, but can you ever get to 0? No, because 20,000 over a number is always not going to be 0, right? Go ahead.
I know how we found 20,000, but I just don't know how we put it in. Like, how did you know to put it in?
Okay, so the first step, Mar, is writing down this. Are you okay with this?
Yeah.
Our first step is finding K. Did we find K?
Yeah.
So we found K, so we rewrote the equation. Here is the relationship between C and X. We now have the relationship between C and X. We know that the cost of manufacturing a syringe is 20,000 divided by the number of syringes.
Which was?
And it tells us that we want the cost when how many? Look right here.
Yeah.
25,000. So where did we plug that in? Right here. And we did the math, and it comes out to cost per syringe is 80 cents. Now, the only thing they add in here, you'll notice that there was something here I did. What didn't I talk about in this part of this clipping right here? The nth power. What's the only thing that changes when it goes to the nth power? What's the only thing that changes? What's the only difference between this and this, kids? One of the x is now to a power. That's the only thing that changes. That's the only thing that changes. So, for example, you could. What is our base relationship? Y is equal to what? K times x to the second. That's the only thing that changes. It looks all super complicated, like all these words are floating around. You're like, oh, it varies directly as a no. If you see square, what is the only thing that changes? The x becomes squared. So it says the time falls disregarding air resistance. That makes the question doable. How many people have taken physics before? Any physics? Does air resistance kind of come into play in realistic physics models?
Yeah.
Say yes. Without air resistance, things would move very fast on the planet. If a skydiver falls 64 feet in 2 seconds, 64 feet in 2 seconds, how far will she fall in 8 seconds? So in this case, which y is going to be time or distance, x is going to be time or distance. Which one do you think is time? Which one do you think is distance? Mar, which one do you think is time?
I think y is distance.
Yes, it is. Good job. And x, that would mean x is time.
Well, how do you know if time's either k or x?
Because k is always a constant. It is never what you're solving for. You're always plugging in for y and x. You also know because how it's written. It says that the distance a body falls varies directly. So whatever the first thing is, that's going to be the y value. So what are we trying to solve for now, everybody? What are we trying to solve for? We've done it 4 times so far in this class. K. We're solving for k. So we're plugging in 64 is equal to k times what? 2 squared, which is 4. Exactly. So we know that 64 is equal to 4k. So k is equal to what? 16. Thank you, Zoya. So now that we have the k value, where do I plug it in, Alex?
You plug it in for that.
Yeah. So what do we now know the equation is?
Y equals
So,
16.
yep, and I'll write it out. Distance is equal to 16 times time squared. That's the relationship that we now have. Now it's asking you how far the person falls in how long?
8 seconds.
8 seconds. So where do we plug in the 8, Nick?
8 squared.
Yeah, so it's going to be distance equals 16 times what? 8 squared. Is that decently big? Yeah. What's interesting about this is this function right here going to keep, like, can you do, yeah, what is that? Can someone just do that? What is it? 16 times 64 is 1024. Thank you. Does that make a realistic amount of sense? Falling 1,000 feet in 8 seconds? Absolutely. Here's the thing. If you factor in air resistance, does this answer change a lot?
Yeah.
It will. Absolutely. Because of air resistance, you have something called terminal velocity. Does anybody know what that is?